Welcome back. This is an Aleks training video on predicting whether molecules are polar or nonpolar. Polar means one side is positive slightly and the other side is negative slightly. What happens is you are sharing an electron pair unequally. So one element is pulling the electron pair closer to itself, making that side of the molecule slightly negative. When the electrons are spending more time on that side and spending less time on the other side, then the other side becomes slightly positive. So you're going to have a delta negative for where the electron is more, and then you're going to have a delta positive where the electron is spending less time. Wherever the electron is spending more time is going to have higher electronegativity. So towards this area of higher electronegativity, that's going to pull on the electron more. And that side will become more negative than the other side. So it gives us three molecules or ions, and then we have to determine whether it's polar or nonpolar. And remember, it's the whole molecule is polar or nonpolar. So you're going to have to do every bond within the molecule, see if each bond is polar, and then see if that polarity cancels out. If it's perfectly symmetrical, it may cancel it out and there'll be no polarity, no positive side and negative side because everything cancels. Or you might end up with a more negative side on one side of the molecule and more positive side on the other, and that would be a polar molecule. So you can have a polar bond, and then you have a polar molecule if those polar bonds add up to one side making more negative and one being more positive. So let's look at this. I've drawn the central atoms of these three that they're giving us here. So we have NH2. Well, NH2, but it's negative. So for NH2, what's it going to look like? I'm going to have one of these be the H, okay, and it's going to have up here it has a lone pair, and then it usually holds hands with three things, okay. But if it's only holding hands with one or two, okay, then there will be a bond. That's a bond. That's a bond. That's a lone pair. And then this guy is open, and that's where the negative is. Okay, so you're going to have essentially a very reactive. That's a reactive molecule or reactive ion. It will very easily attach to something else. Okay. All right. Over here we've got two nitrogens. I've got them opposite of each other because I could tell what was going to happen. I'm going to end up with three double bonds. These two guys are going to be sharing an electron pair. This is going to be sharing an electron pair, and that's sharing an electron pair. So that's a triple bond. And this is not a polar molecule at all because you can see that nitrogen is going to pull on these electrons the same as that nitrogen. There's not going to be a lopsided part to this one. So this second one is really easy. This is going to be nonpolar. I'm not even going to worry about it. Not sure about the first one yet. And the last one, I've got CH4. I've got a carbon in the middle, hydrogen, 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 hydrogen. Okay, so this is going to be a tetrahedral. Okay, because it's four things, four electron groups joining to the central atom, and so you're going to get the jack, okay, the tetrahedral jack. Well, now we need to know, are there polar molecules? Is nitrogen and hydrogen more than 0.5? All right, so I'll look over here to nitrogen. Nitrogen is 3.0, it's right here, 3.0. Hydrogen is 2.1, so 3.0 is minus 2.1 is 0.9, so that's polar. All right, so you are going to, I'm going to draw an arrow just for myself to show myself that this is pointing towards the electronegative element. Okay, so that's going to go going this way. That one is going to be going this way, so I'm pointing towards the more electronegative. And do you see, when I add them all up, okay, I'm not canceling each other out. If I were to have something like this pointing together, that's canceling each other out. Or if I'm pulling on a rope exactly equally, two directions, I'm canceling each other out. Or if I pull on a rope, three ropes tied together at a knot, and we all pull exactly the same strength, that knot doesn't move, the handkerchief doesn't move, then it cancels out. No matter how hard I pull, the other guys are pulling just as hard, and so the handkerchief doesn't move. So canceling means that you're exactly opposite. In the case of this hydrogen-nitrogen over here, it's lopsided. You're going to end up with this side being over here being more negative than this side. And when that happens, you're going to get this side is going to be delta negative, because that's going to be more electrons are going to live over there more. This is going to be delta positive. The electrons are going to sit over here less. So this one is going to be polar. And which one is the more negative? Is it the hydrogen's more negative or the nitrogen's more negative? Well, the more electronegative is the nitrogen, and so this is nitrogen. Okay. CH4, you've got carbon and hydrogen. Okay, carbon and hydrogen. So I look over here at carbon, it's 2.5, and then hydrogen is 2.1. So I've got 2.5 minus 2.1, that's just 0.4. Well, even that doesn't consider itself a polar bond, but even if it were, I've got 4 of them pulling exactly the same strength. It's not a polar bond, and even if it were a polar bond, because they're all canceling each other out, even if it were a polar bond, it would not be a polar molecule. So this one is going to be nonpolar right here. Okay, so this may take a little bit of time because you have to do Lewis dots, then you have to find out where the electrons are headed. Which one's more electronegative, and then you'll have a sided, and then all those bonds have to add up to where the whole molecule has to have a side, one side positive, one side negative. So I hope you're understanding.